page 47 and looking at terms and how to apply them to the atom structure. So first off, the atomic number represents the number of protons So it represents the number of protons in the nucleus of an atom. The number of protons is very important because it determines the identity of the atom. It determines which element it belongs to. The number of protons cannot change in a physical or chemical process. And what's very important to note that if you do change the number of protons, then you change the type of atom it is. So it changes the type of atom. And the atomic number of protons, it is used to organize the elements on the periodic table. So now, the number of electrons. So what's important to know is that electrons during chemical processes, they can be gained, lost, or shared. So the number of electrons may not be the same number of protons in a particular structure. So we have some very important terms that we use throughout the school year: the atom, cation, and anion. See if I can move this up a little bit. So take a look. The atom is our reference point. So I've asked you to memorize the fact that if any structure is described with the term atom, it means that its charge, it doesn't carry an overall charge. Its net charge is neutral. And the reason that its net charge is neutral is that the number of negative charges represented by the electron count is equal to the number of positive charges that is represented by the number of protons in its nucleus. And the atom is our reference point. And from that reference point, we can figure out what is present in the structure of a cation versus an anion. So a cation, it carries a positive charge. And the reason that it carries a positive charge is because the number of electrons and protons is not the same. So here's the thing. The number of protons, this does not change. This number remains the same. Electrons can be gained or lost. So a cation is positive because the number of electrons is less than the number of protons. And the way that this is achieved is that the atom, in order to form the cation, it lost one or more electrons. So the number of protons remains the same. This number decreased. And as a result, when you remove or lose something from your structure, the structure becomes smaller. So the cation will always be smaller than the atom that formed it. On the other hand, we have the term anion. If the structure is described as an anion, then it carries a negative charge. So the overall net charge is negative because the number of electrons is now greater than the number of protons. So we have more electrons or more negative charges present in the structure than we do compared to the number of protons. The way that an atom forms an anion is its number of protons remains exactly the same, but this atom was able to gain one or more electrons, and as a result forms a structure whose net charge is negative. Now, electrons have been added to the structure, and when you add something to the structure, it gets bigger. So the anion will always be larger than the atom itself. The next term is mass number. So if I move it up just a little bit more. Okay. So the mass number is the personal or individual mass of a specific atom. That is the same as you and I stepping on a bathroom scale. The number that reads out would be my personal mass or your personal mass. And for an atom, that personal or individual mass that we call the mass number, it is the sum of the nucleons in the atom's nucleus. So this term nucleon pops up every once in a while. So nucleons refer to whatever is in the nucleus. So this would be the occupants of the nucleus. And the occupants or the nucleons in an atom are the protons and neutrons. So the mass number is simply the summation of the number of protons plus the number of neutrons in that nucleus. Each individual nucleon contributes 1 AMU to the mass of the atom. Now, this is very important, is that the mass number is not listed on the periodic table of the elements. Personal or individual masses are not listed. The specific mass number is either provided or you are asked to determine it using the information given. So we'll make a note of that on our periodic table, which leads us to coming up with the number of neutrons in an atom structure. So the number of neutrons is a piece of information that you will be expected to figure out based on information that's provided. So the number of neutrons, okay, is simply the mass of the atom minus the number of protons in its nucleus. Here is the part that we have to work through. So based on the information that is available when you solve this. So choice number 1, use a mass number, the personal mass, if it's given or known. If the atom's personal mass number is not available, then number 2, this would be our default choice, is to use the average atomic mass that is listed on the periodic table, and we need to round it to a whole number. So the masses that we see listed on the periodic table are what I refer to as general population mass. So like when data comes out in the news about a health report and it provides the average weight or cholesterol or blood pressure of a particular group of people, that data is not specific to one person, but it's an average of the population that was looked at. So on the periodic table, it's an average mass of the atoms that make up that element. Now, one way to represent information about a particular atom is the atomic symbol. So here we see the letter X, and X represents the element's periodic symbol. Upper left-hand corner, A, this represents the mass of that atom, and that mass is information about the protons plus the neutrons. So protons plus neutrons. The lower left number, Z, in the position of Z, this represents the atomic number of the atom, which is the number of protons.